Hello everyone, thank you for joining us. My name is Asmin Daher. Today's presentation, Conservation of the Local Finishes, Plaster, Murals, and Flooring, will be hosted by Nathalie Chahine, an architect restorer who has been involved in research and rehabilitation projects in the Ottoman cities of Tripoli, Saida, and Damascus, and also a member of BBHR. Nathalie, the floor is yours.
So today we are going to talk about the historical finishes in the Beiruti houses. More precisely, the lime-based plaster and the painted ceilings, the Baghdadi technique, the ornamented molded plaster elements. First, we are going to start with the lime-based plaster. I'm sure that most of you who were working on restoring the houses that got affected by the blast often heard experts and architects working in this field requesting them to use the lime plaster instead of cement plaster when plastering the sandstone walls. Why lime plaster, and what is lime plaster, and why not cement plaster? If we want to understand really why this material is very important, we just need to observe what was used previously. And while looking at Beiruti houses, we noticed that most of them had all their facades covered with plaster. So it was the facades were coated, and this plaster is lime-based plaster. And when the facade was not plastered, it was the main facade, most of the time the north facade, but the stones had their joints nearly tending to be zero, so the joints were really very fine. And this tells us a lot. This explains to us that the builders, the masons, knew that the sandstone was vulnerable and it was not meant to be exposed because it's a permeable stone and it has a very low compressive strength that even gets lower when exposed to water, rainwater. So this is why they decided to coat and to plaster these stones. And they left what they considered to be the main facade unplastered. However, several observations allowed us to discover that these facades, even if they were not plastered, they were covered with lime wash, which is a mix of lime and water and a kind of pigment. And that was supposedly repeated on yearly basis. So even when they plastered, sometimes because they apparently they liked the stones and its pattern, so they imitated, as we can see on the picture on the right, they imitated the pattern of the stone when plastering. And this imitation had many shapes and patterns. For instance, on the left, we can see a plaster that covered, in this case, a fence of a Beiruti house. And we can see the technique, how they used to do this plaster. So they used to make a groove. And then in this groove, they installed this kind of joint, 1 centimeter approximately. And this joint helped giving the pattern of the stone with the same height of the stone and width. Another technique would be the Tyrolean gun, and this technique allowed them making several motifs, stone pattern amongst others. What is lime plaster? If we go and if we have a closer look to a plaster that was applied on a sandstone wall, we see that first we have the wall, the sandstone, and then we have a layer which is a little bit reddish with a small dots, white dots. This layer is made of clayey earth stabilized with lime inclusion. So if we want to be very scientific, we won't call it a lime plaster. We would call it earth plaster stabilized with lime inclusion. This is the scientific terminology. The second layer is lighter, so it has less earth, more sand, and more lime. And the last layer, which is nearly white, has big quantities of lime mixed with either sand or stone powder or marble powder. So why they used earth? They used earth because it was the most available and cheap material. They were surrounded by earth, so why not using earth? But since earth cannot be stabilized even when mixed with water or straws, so they had to add these small quantities of lime as a binding material to bind the material all together. And then in the second layer, it was more it was less so quantity of earth, more quantity of sand and lime, and this layer was used to give a straight surface for the plaster, and the last layer to give this smooth surface. And the final layer would be lime wash, or what we call in French badigeon de chaux, and it was mainly based on lime and water and pigments if they wanted to give a certain color to the facade, which was very common. We forgot to mention that in the mixes, they used to add aggregates. What are these aggregates? So these aggregates are, like we see in this first picture. This is a very close picture of a lime plaster, where the smooth surface has disappeared due to weathering effect, but we can still see the small sand particles. So why they were using sand in the mix? Because the coarse sand preserved the plasticity of the plaster and reduced the effect of shrinkage, because plaster tends to shrink right after it is being applied, due to humidity, to heat, to several factors. If we look closely to the one beneath the upper picture, we see those lime inclusions we were talking about, and we see another type of aggregate, the cattle hair. The most common were the goat hair. In Europe, the most common were horses' hair. And so these hair, and they could be as well fine plants like here or straw. The role is to increase the tensile strength of the plaster. And you can experiment this. If you remove a piece of plaster and try to break it, you will see that it's not that easy to break because it has those fibers in it. And now even when we apply new plaster, we put most of the time fiber, not necessarily organic fibers. We can use industrial fibers like synthetic fibers or another aggregate, and this is very important, the crushed brick or terracotta and coal or ashes even. And the role of these aggregates is to add and reduce, to reduce the setting time. One of the inconvenient or characteristic of the lime, the setting time. For example, when applying a plaster, you should wait approximately 2 to 3 weeks for every layer to dry, to set. So the Romans, they found a solution for this problem, and they added puzzolanic materials such as volcanic powder. Well, since here we do not have volcanoes, people used to add terracotta or crushed bricks or coal, because coal takes humidity away from the plaster, and so it helps increasing or decreasing the setting time. Last thing to say is when we add those bricks and terracotta or puzzolanic material, we say that we increase the hydrolicity of the lime, because what we have, we call, what I've already explained, is called the quicklime, what was previously used in old times in historical houses in Beirut. It is called quicklime, okay? So quicklime needs a lot of time to set. by adding those materials, the time was being shorter, and this is when we call the lime a hydraulic lime. Nowadays, some factories are producing ready mixed hydraulic lime, which we call commonly NHL or NHL. With a small number. This small number indicates the compressive strength of the lime. So the natural hydraulic lime is faster in drying, so it's easier and faster to use. But you should pay attention because the NHL, so the natural hydraulic lime, sometimes it is followed by the letter Z. Whenever you found Z, it means that it has additives, and those additives could be cement. So you have to check the data sheet. And whenever you have HL and not NHL, it means that there is cement. It's not natural. There is cement inside. On the local market, for example, we have HL5, and this cannot be used for plastering and cannot be used for jointing because it has cement in it. And you really want to avoid using cement in either plastering or jointing. I will explain that later on. So this is a brief sketch to explain the preparation of the quicklime. And we still have a kiln in Batroun area where quicklime is being produced. So basically, they use the calcium carbonate, or CaCO3, which means the stones, the limestones, and they burn them for 7 days. And at the end, they have what we call the chaux vive, or slaked lime. They take this lime and they add water to it. And when they add water to it, you have like extinction, and you have a reaction, like you see here, a chemical reaction. And this is very dangerous. It's not dangerous. I mean, the people should know how to handle it. They should wear gloves and glasses, not like in the picture. And then this lime can be stored in basins or in barrels with water covering it for years. And then it can be used in the lime application whenever needed. So whenever it is needed, the mason or the plasterer will sieve the sand, and he has the quicklime ready. He adds the quicklime to the sand, he mixes them together, and he starts applying the first coat, which is called the rashet mismar, or the key coat. And it is used to bring the surface to a level plane. Usually the mix is 1 part of lime putty with 2.5 parts of coarse, sharp, well-graded sand. The setting time, as you can see, is 2 weeks. So we cannot apply a new layer before making sure that this layer is ready to receive a new layer. The second coat, or ورقة الأساس, or the leveling coat, the mix varies with the finishes that we need and we are requesting. And usually it is 1 part of lime with 3 to 2.5 parts of sand, plus aggregates. That you can see in this picture, the aggregates are consisting of crushed terracotta. The tools that are used are the normal tools that are being used in all plastering works, in cement plastering and all kinds of plastering. So the floating ruler, or the idde, the sponge, and the devil floater, and the wooden float. So they adjust the level, and then when the mix begins to stiffen, they consolidate the floating coat by rubbing up, so بيفركوا, the surface using a wooden float in order to counteract shrinkage. Otherwise, you will have cracks appearing in this coat. And then the final coat is made with, some people add sand, some people add stone powder, some people add marble powder. Marble powder gives the surface its shiny effect, and it is like used as a waterproofing material. Some people would add, for example, after this coat dries, they rub it with oil, uh, different types of oil, in order to make it waterproofing material. What are the types of decays that can be encountered in in this material? First, and as you may have noticed after August 4th blast, the detachment. And as you know, the plaster is supported by the stones. So whenever there is a movement, a structural movement in the walls, it will affect the plaster and it will appear on the plaster. So after the explosion of August 4th, all the walls shaked in the Beiruti masonry houses. And this is why we witnessed this detachment in the two upper photos of the plaster from the support. The cracks as well, they can appear following a movement in the walls, and the ceilings, and the house in general, and sometimes due to water infiltration or to fatigue in the plaster itself. The last, the picture on those first, the detachment and the cracks, I will talk about several actions on how to treat them later on. But for the powdering, it is mainly due to moisture and water accumulation. And unfortunately, there is no solution. For this plaster, it needs to be removed and new plaster should be applied. When it becomes powder, nothing can be done. But most importantly, and this applies on all restoration actions to be done, you cannot treat the effect before treating the causes. I mean, in this picture of the wall, if you didn't treat the cause of the moisture that led to the powdering of the plaster, you could not reach a final solution. Even if you applied a new plaster, the same will occur, and the new plaster will show powdering effect after a certain time. So first, treat the cause. We can see in the picture on the left, moisture and microbiological patina, and this is when you see green coloring film on the surface of the plaster. And of course, the reason is the humidity and water infiltration. This can be easily solved whenever you stop the water source. You should open and ventilate the space in order to let the humidity out. And after a certain time, maybe at the end of the summer, you will notice that the green color became black because the microbiological patina died. So this is when you can scrub it and remove it. And now, if this persists and was not easy to remove, you can then use but this is not recommended, what we call quaternaire d'ammonium. These are salts that attack the biological patina and remove it. But unfortunately, they bring lots of salt to the surface. So you have to wash repeatedly after the application in order not to keep any traces of salt on the surface. The second problem is the action, the human action. And we have witnessed many sites that were restored in a bad way after August 4th. I took this picture from one of the social media of one of the NGOs showing the guy plastering and using black cement on the wall. Why this is a bad intervention? It's not a trend to use it or not to use it. I mean, before in the 90s and before, it was not known. It was not really yet spread that it's a wrong material. But now that everybody knows that this is wrong to use cement, it is not allowed to use it anymore because, the stones, especially the sandstone, sandstone is a very, as we said, permeable material. And when we apply the cement, whenever there is a humidity or a moisture, the water will infiltrate through the cement, because you can never ever stop the water from entering. There still be some cracks or a small failure where the water could find its way and it gets into the wall. And so the water will bring the salt that are highly, there is a high content of salt in the cement. The water will bring the salt will migrate with the water and will enter in the stones. And then it will stays in the small holes, because the sandstone is a very porous stone. So the salt will sit inside those holes, and with time it will crystallize and it will create small stresses and failures and cracks, micro cracks inside the stone. And you can imagine with the time the result of this effect. Moreover, as I said, the water will find its way inside, but it won't be able to go to find its way outside. So it will be stuck inside the stone, and the house won't be able to breathe. And one of the particularity of the heritage houses is the breathability, and this is very important. It's like, imagine your skin, that one day you decide to obstruct your skin, and imagine what could happen. And another very, very important factor, we always think of how to prevent water from entering the house, and we never think of how to make water inside the house go out. We always forget that human activity generates water inside the house, either from condensation, activities, cooking, respiration. So if we put a film around the house, if we plaster it with cement and or put water repellent, then the water that is inside the house won't be able to find its way to the outside, and it will remain stuck inside. And this is why the use of limestone, of lime plaster, is important, because it's the same, it has the same characteristics like the stone. So it's like, for example, when you replace something with something else, you should use the same characteristics, or else there will be a failure somehow, somewhere, someday. And using the same characteristic with coating applies on the plastering action. Now, the last picture on the right shows the efflorescence effect, which is the salt, actually, that you can see on the below picture. And this salt comes from the cement that was used inside the house. So the salt migrated to the outside and made the whole plaster crack and fall. In this case, you should remove the salt, of course. You should stop the source that has the salt in it and plaster again. One note, when you remove the salt, never throw it on the base of the walls. Just remove it and take it away, because if it's on the base of the walls, whenever there is rain or humidity, it will migrate again through the structure. These are the three last problematic problems. The stains that comes from the rust, they can be easily cleaned and the rust removed from the metal. The chromatic decays, we're going to talk about it tomorrow when talking about the paintings. And the salt and the dust deposit, it can be easily brushed and removed. Now I'm going to show a small operation that was conducted on a detached plaster. This is to be done by specialists or by skilled people or by skilled craftsmen who know how to consolidate and who know the characteristics of the materials and the chemistry of the materials and the construction technique of these materials in order not to make irreversible actions. So first, we attach the crack using thin gauze and spraying with a special product. It's paralloid, and then we edge the existing plaster As you can see, in order to avoid any injection coming out when doing the injection, and of course, we edge it with plaster, lime plaster, and sand. And then we make the injection through holes that we do before finishing the edging. And then this mix is made out of a lime mixed with water. It is very important to do every 50 centimeters, wait for 3 to 4 days, and then proceed with the upper 50 centimeters. You cannot inject a wall one time because there might be a risk of further cracks or of collapse of the plaster. So as you can see here, we did the propping, we did the injection, and then we did a higher propping with a higher injection. And you will need, of course, at the end, the retouching from a skilled painter to make the camouflage of all the actions that took place. Last point to talk about is related to something that usually the structural engineers talk about, which is the weakness of the lime plaster whenever they want to consolidate masonry walls that are showing structural deficiencies. Structural engineers usually put a metal mesh and they put above it cement. And you know, we cannot put lime above it because lime attacks metal, iron. And at the same time, structural engineers do not trust this material when it comes to structural consolidation. Well, it's been more than 20 years. There is this material, the glass fiber mesh, with its special connectors, and it's being used and tested mainly in Italy, and it works very well on consolidating masonry walls. Michel talked about it 2 weeks ago, and it was used in Lebanon. It was used in residential and archaeological sites, and it proved that it's really effective. So you put the glass fiber and then you plaster again with hydraulic lime and you get a good result. So there are no more excuses not to use lime plaster. And the lime plaster, the quick lime plaster, for those who cannot afford natural hydraulic lime plaster, they can get the quick lime plaster locally made, and it's not at all expensive. Now I move to the second chapter, the painted ceilings. The painted ceilings are a very important feature in the Beiruti houses. Unfortunately, it was very affected after the blast, and we counted around 70 Baghdadi ceilings, beautifully painted, that were heavily affected. Now let's try to understand the structure of these ceilings and how they are built and done. Well, if we look at this picture, let's try to understand how it is made, not in terms of painting, but in terms of materials and structure. Basically, we have three ways that, or three supports, potential supports. First, the painted ceiling could be applied on a limecrete slab. The second, it could be applied on a jack arch slab. And the third one, it could be applied on a Baghdadi ceiling. And this is the type that we are going to develop in the presentation. So you have these lats, and following the blast, most of you were able to see the structure because parts of the Baghdadi collapsed and everyone was able to see the wooden lats. So how are these wooden lats attached to the ceilings and to the Baghdadi, and why the plaster does not fall, and what is the type of this plaster. What is it made of? We should go up in the attic whenever it's possible in order to understand the technique of this material. As you can see in the picture on the right, you can see the lats of the Baghdadi that are nailed to the wooden beams, and the wooden beams are attached to a main beam, not necessarily an I-beam. In this case, it's the case. And then if you look closer, you will see the wooden lats and you will see the plaster, and in between protruding plaster going higher than the lats. This technique is called the Baghdadi because it was brought from Baghdad, where painters used to cover the bamboo with gypsum and paint over it, jarsin. But in Beirut, the bamboo was replaced with wooden lats, and the finishing varied between lime. In most of the cases, it's lime, and in few cases, it's gypsum. And when it comes to the edge of these ceilings, sometimes we see that the ceilings ends up with a curved line. And if we go again in the attics, we will see that this Baghdadi is as well made of wooden lats that are attached to wooden curved elements. And these are attached to the wall, or if there is a beam, to the beam, or they are nailed to this beam. So there are various ways to attach these wooden curved elements. When it comes to the material, the wooden curved elements, as well as the Baghdadi, can be made of otrane. Otrane means the wooden cedar that is treated with goudron. Goudron in French became cotrane, which is a material made of, which is a resin that is extracted from the pine trees, I think. So the curved wood is either made with otrane, but in most of the cases that I personally have observed, it was made with pine tree, with pine wood, sorry, shouh, as well as the Baghdadi's lats. If we look closer, this is a picture of a detached plaster. What you can see here is what we call the key of the Baghdadi. And this is what holds the plaster to the wooden lats and doesn't make the ceiling falls, the plaster falls. So the plasterer will apply the first layer and pushes the plaster in order to enter between the two lats, and then you will have the key, and whenever the key will dry, it will attach the ceiling to the lats. As you can see here, you have the timber joists, and you have the lats that are nailed to the timber joists, and you have then the setting coat with the plaster keys, leveling coat, and finishing coat at the end. Here, for example, we can see the plasterer trying to apply the first coat. So he pushes the plaster, and then the plaster will go inside the keys, the lats, and you will have the keys that will hold the plaster in its location. And then you will have to wait. If it's quick lime, you will have to wait for 1 to 2 weeks until it dries before you apply the new coat. As for the mix is the same as the plastering of the walls. It's the same mix. Now, when it comes to those modeled and casted elements, these are for sure made with gypsum, because there is no way where we can cast lime. I mean, if you bring a mold and you pour lime in it, it won't work. You cannot pour and mold lime. Gypsum is made to be molded and to have identical elements. It is known that before, I think, the 19th century, in Europe, they used to make such elements and motifs with lime, but it took many months to be finalized. For example, if you have to make this flower, you will have to make the first layer and then wait for 1 to 2 weeks and then make the second layer and the third layer until you get the flower finalized. And then they started casting elements with gelatin moldings. Then if you have the molding, you will be able to make, for example, this flower, you will be able to make 100 examples in 3 days. And this was the practicality of the invention. And if we want to think of how these elements were attached to the ceiling, where if you look closer here, you will, where the red arrow, you will see those rusted traces of the iron, the metal bars that used to connect the gypsum elements, the molded element, to a beam, to the wooden beam, as you can see here. So basically, this is how they used to attach the elements to the upper ceiling by the means of metal connectors. And this is how they were able producing such beautiful ceilings and such beautiful elements in such a short time. These are more examples. And basically, this is how these molded elements are being applied to the ceiling in order to get a result that looks like this at the end. As I previously mentioned, some of the ceilings were made with gypsum. So and this is easy to recognize and this is easy to know, because you will have, for example, like this one, it cannot be made manually with Baghdadi lime plastering. It has to be casted and then applied to the ceiling. So this is done with gypsum. But whenever you have flat surfaces and decorated motif applied to them, this is for sure lime plastered Baghdadi. Now, when it comes to the corniche, of course, as we previously said, it is made with gypsum because it is a molded element, and it is attached through wires and metal bars to either the walls or sometimes the wood structure. It depends. And these are examples of corniche and Baghdadi. So basically, you have this ceiling made with wooden lats covered with Baghdadi. Same applies to the curved part. And then you have the corniche made with gypsum and applied to the wall. Another example. It is very important now that we will soon start talking about the decays of these elements to know that lime can fight weathering. It can be exposed to water because, as we previously said, we plaster facades with lime. However, the gypsum cannot fight water. You cannot expose it to water, to rain. And this is why whenever you have water infiltration inside the house, it's the gypsum that gets affected the most, because it cannot, as we said, fight the water and the humidity. And unfortunately, whenever we have a situation like this, it's not reversible. So we cannot use those corniche anymore, and we cannot restore them unless we want them, we accept having them like this without any relief and without any motif, but usually they cannot be restored. And this is a very easy test for you in order to be able to distinguish if the material that is being used is lime or gypsum. You just need to put any acid on it, lime, vinegar, and if you have this effervescence effect, then you can be sure that it is lime and it's not gypsum. On the picture below on the right, this is gypsum, so there is no effect. However, we have traces of the metal that got rusted, and these are the remaining of the iron bar that used to hold this gypsum molded element to the ceiling. Now, just to mention that we have Baghdadi ceilings and we have Baghdadi walls as well. The technique is the same, the materials are the same. And these walls are not partition walls, they are not structural ones, and they do not bear any load. Now, talking about the decays, the cracks, we have cracks that are caused by a structural deficiency, because again, this is like the plaster, it's an element that is attached to a structure, a wooden structure, and the wooden structure is attached to the masonry walls. So everything is related to each other. So whenever there is a movement, the Baghdadi is going to be affected. We have several types of cracks. On the right, as you can see, the cracks follow the direction of the Baghdadi. Yes, so in this case, we can say that there is a structural movement in the house. So the Baghdadi moved and then the plaster cracked with this movement. Now, in order to solve this problem, we need first to monitor it. Maybe the movement ceased and is not active anymore. And we need to find out why the ceiling moved in order to understand why we do have these cracks and then try to solve them. On the picture on the left, the ceiling shows several directions, which is most probably due to aging effect and fatigue of the plaster itself, because this is a ceiling from 1890. So after all these years, the plaster, it is very normal that the plaster shows aging and fatigue, and the solution is easy. The cracks can be grouted and filled with the proper material, and then the painting retouched. As we previously said, the poor water management can lead to the total collapse of the ceiling, not because the lime is vulnerable to the water, but because it is attached to the wood, and the wood is vulnerable to the water. So, for example, in the picture on the right, it's the continuous exposure of the wood to the water that led to the collapse of the lats and then the collapse of the plaster. Because if you see here, the plaster is in a good condition, but the wood is in a very bad condition, and sooner or later it will collapse. And same goes for the areas of loss and lacuna. They are caused by infiltration and of water from open areas. Flaking paint, we're going to talk about it tomorrow. This is when the paint is affected by the condensation. Again, the condensation is not water coming from outside, is water generated by human activity inside the house. Here we have the same situation. We have the water coming from up and affecting the Baghdadi, the plaster. The plaster can be treated, but as I previously said, the corniche is in a really bad condition, and it's really difficult to restore it because the sulfate, the one of the element of the gypsum, is really deteriorated, and it's really very, very difficult to restore it. And in all cases, all the ornamentation and the motifs are lost. This is an example on the left of a ceiling that is located in a house in the first floor. So the floor above this Baghdadi ceiling is not the roof. So there is no water leakage from up. However, there is a toilet that was added just beneath the ceiling. And what you can see here is the result of the condensation of the water on the ceiling itself. So it's the water from inside and not from outside. On the picture on the right, you can see deterioration and decays on just only one part. So most probably there is a direct water source located just above this area. Fortunately, the area that is adjacent to the affected area is sound, and this is very common. You could find some really affected areas adjacent to very sound areas. So, and this is very good because then you will have only to treat the affected area, and the ones around it are fine and do not need any kind of intervention. Again, this is the same. This is when the painting is affected because the plaster behind it is affected. And we talked about this problem before. It's when the ferrous armatures are getting rusted, and then because they are exposed to water, of course, which lead to deterioration and collapse of the modeling. Like here, for example, there was a flower like this, and here there was a small corbel like this one, and here, and all are lost because of the humidity. The corniche, of course, it will be very affected by any water infiltration. Whenever there is a physical failure, the corniche will fail. Whenever there is water infiltration, it will get affected. So it's a very vulnerable element inside the house. And whenever even the Baghdadi lats are being attacked, this is as well an element that could contribute to the collapse of the corniche or the Baghdadi. In this case, the corniche crumbled and fell down. The human interventions, as usual, can be very harmful. On the left, we can see the intervention that was done by the person who was living in this room. So there was a piece of Baghdadi that disappeared, and he replaced it with gypsum, which is not the proper material in this case. And second, without giving any trouble to at least follow the shape of the Baghdadi. And the picture next to it, I took this picture as well from one of the websites of an NGO working on heritage sites in Lebanon in Beirut after August 4th. And they are applying cement plaster to the Baghdadi. I could assure you that this won't last because first, the cement is very heavy. The wooden lats won't be able to hold it for a long time. Second, it is a hard material, and you know the wood is a living material, so it expands, it moves. So if it is attached to a hard material, one of the two materials will crack, either the wood or the cement. And reaction to heat, cement and wood is different. So of course there will be problems in the ceiling sooner or later. So we hope that this kind of interventions won't take place anymore. I'm showing this picture to tell you that sometimes even the builder or the person who did the Baghdadi did not do it in a perfect way. On the right, on the left, there is an example, a close view to a ceiling in a very bourgeois, in a house that was owned by bourgeois families, and it was highly decorated. However, the structure, the things that was hidden, was not properly done, because instead of using long lats like we usually find in houses that have Baghdadi ceilings. The guy, he used very small lats that are that have the length of, I don't know, 40 centimeters approximately, and on all the floors. It's not an exception. He used it everywhere, and this was really bizarre, and we couldn't find an answer except that he was not skilled, maybe. This is why he used very, very small lats, and they were not even aligned. They were put in a very random way. Now, after August 4th, as I said before, we lost many of the Baghdadis that we had because they are attached to the timber, wooden timber roof, the charpente. And as Jean explained last week, this was the element that got the most affected because of the blast. And so the Baghdadi, of course, as a result, was heavily affected, and we lost lots of really, really precious ceilings that we had and that were still standing. Now we have a big responsibility making interventions on these ceilings. Nothing can be taken for granted. We cannot put amateur to do the work. You would need really handy people. You would need craftsmen, as I previously said, who are familiar with the material and who know how to deal with this material and the characteristic of these materials. So this is the ceiling on the right. We had only a small failure that was very easy to treat, and because of the blast, we lost more than half of the ceiling. When making an intervention on a Baghdadi ceiling, like on any work of art, the restoration could harm this work of art, and it could reduce its life instead of enhancing its life. So we need to examine the condition, to the degree of damage. We need to know the nature of the materials and the technique of the materials and the history in order to minimize the intervention and maximize the preservation and reinstate the aesthetic integrity of the ceiling. For example, if I have a ceiling like this, it would be really a big mistake to decide to remove all this part just because it is sagging or it is detached from the wooden lats, when in parallel there is methods how to bring it back and reattach it without losing the aesthetic integrity of the ceiling. This is an example of how, for example, a mapping is done on a ceiling where, for example, the cracks are being marked. The cement, because there was a previous maintenance or intervention on the ceiling that replaced the lime with cement. As you can see here in the lower picture, you already can notice the difference, and you can see the crack because they use two different materials. There must be a crack between the two materials, and the lacuna as well are indicated. So basically, there were four kind of problems: the detached plaster, the cracks, as you can see here, the lacunas, and the later bad interventions, the use of cement, etc. In any restoration or intervention on a Baghdadi, there are some preparation works to do first. We need to prop the Baghdadi, because first we need to restore the structure, which means the charpente. So meanwhile, we cannot leave the Baghdadi as it is. We need to prop it. Sometimes before the propping, we need to reattach some detached, really detached, severely detached plaster with what we call Japanese paper. And then when we install the propping, we add some materials that are not, some flexible material, like, for example, foam pad, to be in contact with the fragile plaster. And then the next step would be to make the restoration of the wooden structure to finalize it. Then the upper part is cleaned with vacuum in order to remove all kind of dust and debris and etc. And then we start inspecting the lats, the wooden lats, because as I said, as a wooden material, if it was exposed to water, there is a big chance that the wood is rotten or being damaged. So it is treated. And when there is a chance to replace it, we replace it. Like here, for example, the lats were replaced. And if you notice, and this is very important, when you replace, try not to create a continuous line. For example, here we had two longer lats, and here a smaller one. And this is to prevent any continuous line. It's the same when you do the stitching, for example, on the walls. You cannot have a continuous line because it will create a weak point when you have continuous lines in the walls or in the wood or whatever. And jute was added between the two and the new and the old with some vinyl in between. And then in this case, the ceiling was made with lime. So the lacuna were filled with lime. When you have a ceiling that is done with gypsum, you do it with gypsum. And in the areas that were sagging and detached, there was a plaster added from above as well as kind of injection to so the plaster was pushed up and the void was filled with lime from up, while adding as well jute as it's kind of net that makes the material stronger. And in the lower picture, we filled the cracks with lime whenever there are cracks, and the cement that was added in a later phase was removed and replaced with lime. Then the motifs, the decorated motifs were were copied, if we can say, by applying silicone in order to have the same shape. And then these silicone molds were filled with gypsum. And this is where we started collecting and making the puzzle of the motif at the angle, because you cannot make it at once. You cannot make one mold at once. First, you have to get the drawing, because basically this is a mirror. So you only need this part, and you don't do the silicone on all this part, because at a certain point it will cause the detachment of the still existing motifs. Sorry. And then the motifs are attached to the ceiling with the stainless steel screws. And finally, all the motif is being attached and the lacuna is being filled. And this is where the role of the painter, the skilled painter, comes, where he should make a harmonization of the new added part to the existing part. And the corniche, of course, showing cracks, will be consolidated, and the cracks will be filled with gypsum in this case. Sometimes additional conservation materials are being added to the mix in order to give it a better strength. And of course, as you can see here, the painter did his retouching while keeping the traces of the crack apparent. Finally, it is very important to, whenever we have tableau or complete drawings on the ceiling, to try to rescue them and not disregard them. You will be able somehow to reattach, even if not a complete drawing, even if it's a small part. It's worth it to do it, because these are historical elements that should not be lost. So this is what was done in this case, and this is another example of volunteer students who volunteered with the BBHR mission in 3 houses affected by the blast. So the corniche were stored and sorted in order to be used to take the motif and cast new elements. And on the right, you see the volunteers trying to find the small pieces that would constitute specific drawings in order to reattach them on support. It's easy to reattach. You should put a mesh beneath and just try to glue it on the mesh and reattach it to the ceiling on its exact location, hoping that you would have the survey of your ceiling before the blast in order to locate the drawing in its previous location. And finally, this is a message of hope that I wanted to put at the end of my presentation. It's extracted from one of the ceilings that collapsed because of the blast. Let's keep hope and let's keep the good work using the right techniques, the right methods, the right materials, because Beiruti houses deserve the best from us. Thank you.
Thank you, Nathalie. Thank you so
much.
Thank
you, Yasmin.
We have a first question from Hussein. Are you sure that the Baghdadi origin comes from Baghdad? As I know, the word means in Turkish made of lath and plaster, and it is observed a lot in wooden Turkish architecture.
It is observed in Ottoman architecture, of course, and this is not a technique that is specific to Baghdad. I mean, even in Europe, they use wooden laths and they cover them with plaster. This is not specific to Baghdad. Now, according to the word Baghdadi, I don't know Turkish language. I have no idea what does it mean in Turkish. But if Hussein is sure, this could be an interpretation of the terminology. And this is not, I mean, it could be from Baghdad and it could be from Ottoman influence as well, because it's a technique that was used, that was not only specific to Baghdad. So it could be correct. And what I use as information is from a reliable source. So, but you know, in history, sometimes it's really not clear to define where does this come from. Even the central hall, it's still not clear. There are still lots of historians who say that no, it's from Istanbul, it's Ottoman. Other people would say no, it's the courtyard that is being closed. So in these cases, it's really difficult to track really the source of the element of the typology. So it could be what you're saying, Hussein, it could be correct.
Thank you. I have a particular question. With the blast, we saw that most of the plaster actually did some bubbles where it didn't collapse. It wasn't on the floor. It was still hanging on the wall. But if we touch it, it would fall very easily. Is there a way to restore this?
Yes, there is a way, because what I showed was an example of what you're talking about. It was a part in the middle of the wall that made like a bubble. So around this bubble, you will find cracks. So you will need, as I said, to reattach those cracks and then to inject in order to fill the void. But before injecting, you need to put it back as much as possible to its original place, you know, to push it back and to prop it. As I showed in the picture, there is a propping.
So it was the propping technique.
Yes, the propping, and then you inject, and then it's on its place. You leave the propping for 3 days and you remove it.
Okay.
It should work.
It should work. Perfect. Yeah. Okay. I don't think there's any other questions for today.
Okay.
But the presentation will continue tomorrow.
Okay.
And we hope to see you all tomorrow.
See you
Thank
tomorrow.
you so much, Nathalie.
Thank you, Yasmin. Bye.